If you want to learn how you can build your first token on a blockchain or build on a blockchain in general, then you need to watch this video. By the end of it, you will master ERC20 tokens by first learning what an ERC20 token is, second, writing Solidity code to create one, and third, deploying it on the Celo blockchain. Subscribe to this channel to improve your blockchain skills and knowledge weekly. By the way, if you'd like to learn while you earn, then you can earn 100 USD by completing this course where you learn how to build your first blockchain application on the Celo blockchain. You can sign up using the link in my description and make sure you complete the Celo 101 development course and submit your own work to be able to receive the reward. On a blockchain, a token is anything that we would like to interact with using code, or in blockchain terms, a smart contract. The most common thing to be represented on a blockchain is a currency, but a token can actually be used to represent anything, for example, votes, the deed of a house, or even shares of a company. So tokens can actually be equivalent or identical, which means they're mutually exchangeable, and they are called fungible tokens. So for example, if you have $1 and I swap it with another $, the value is still the same. I still have $1. So a $, is considered fungible. In the blockchain space, when we speak about ERC20 tokens, they are also known as fungible tokens. And you may have come across non-fungible tokens, and with non-fungible tokens, they are not equally unique or identical. They cannot be mutually exchanged for the same thing. So if I have one CryptoPunk and you have another CryptoPunk, they may carry different weight and value because they have unique attributes. So to create a token, we would need to write a smart contract, which means we're coding, and then deploy it on a blockchain. This smart contract defines various methods or functionalities that the token can do. For example, you can transfer the token from one account to another. The smart contract will also define various variables which will store information, for example, the balances of each account holder. So for example, there's information stored on the blockchain saying that this address owns this many of X token. So how do we go about writing a smart contract for a token? Thanks to Fabian Vogesteller and Vitalik Buterin, we have a standard which we can follow when we are creating ERC20 tokens. This standard is followed not only on Ethereum, but also Ethereum-like blockchains. There are other token standards such as ERC721, which is a very popular token standard for NFTs, and there's also ERC1155, but in this video we'll stick to ERC20. So to create an ERC20 token, we have to follow the ERC20 token standard. By following this standard, it makes it very easy for other applications to use your token within its application. So for example, MetaMask is a very popular wallet software that we use to interact with the blockchain and manage our account. So if I create an ERC20 token, then it can easily be represented within the MetaMask wallet. So the functions within the ERC20 token are listed here. And these functions are to be implemented in our code when we create our own instantiation of an ERC20 token. There are actually many implementations of these methods, and within the EIP20 documentation, you can see two of them. So for example, one from OpenZeppelin and one from Consensus. So in this video, we are going to follow the one provided by OpenZeppelin. OpenZeppelin offers really helpful resources when interacting with Ethereum and building for Ethereum, and they also have security in mind. So let's go to the Remix IDE to start writing code. Okay, so let's begin. So first go to your laptop and open the Remix IDE. So if you just go to remix.ethereum.org. And like I said, we'll be following the OpenZeppelin implementation. So open Remix and then create a folder and call it fungible tokens. And then within that folder, you can create a file called anything really. So I'm just going to call it my token.sol because it's the Solidity file and that's the file ending. And then you start off by pasting in the compiler version. So I wrote Pragma Solidity, so I'm taking version between 7 and 9. I think right now it's version 8.1, 0.8.14, I think is the current version. So let's just start off by naming our contract. So we use the contract keyword because that indicates to the compiler that we're creating a contract object. And we're just going to name it for now my token because I'm really not creative at the moment. And then just leave that blank. So like I said, when you create an ERC20 token, you have to basically implement the ERC20 token standard. So in programming, we normally have something called an interface, which is an abstraction, which you can use to inherit from because it might have like methods and stuff that every object that inherits from it should practically follow. So for example, you can have an interface for a car. Every car has an engine, every car has a brake, every car has gas, etc. And then you can implement various types of cars. So you might create your own object called Ferrari, and you'll inherit from the car interface because even if you're a Ferrari or Tesla, you probably are still going to have the basic functionality that all cars have. It's the same thing here with interfaces. So we are going to copy the interface required for the ERC20 token. So if we look at the OpenZeppelin implementation, they've actually imported it from their own libraries. But to help you understand it a bit more, we're going to copy paste the actual code. So if we just navigate to this location here, so it's probably inside of this folder. And I have here ERC20 sol. I'm just going to do raw, so I can just copy everything except the compiler version, and boom. So we have now pasted in the ERC20 interface. So as you can see, it has a bunch of functions that have not been implemented, like total supply, balance of, allowance, etc. It even has some events, which we are going to utilize as well. So events are essentially logging for the Ethereum blockchain. Whenever you emit an event, that means there's information that's printed to the blockchain that anyone can see, which makes it easier for logging, debugging, and also doing things on your interface. So yeah. So now that we have that, now we can inherit from this interface. So to inherit in Solidity, you write is, which is a keyword of like, oh, I am a child of, this is a car, this is an ERC20 token. So I'm going to say is ERC20, which is what we named it there. And then the compiler will complain when they're saying like you're missing an implementation. So we have to not implement it. So let's go through the ERC20 contract from OpenZeppelin. So they've also inherited safe math. We'll talk about safe math a little bit later, but for now, let's just go through the basic stuff. So first off, they are saying that they would like to create a mapping of address to uint for the balances. So remember how I said when you have a token, you basically have various functions and methods. But one of the main things you would like to know is who actually owns this token. So by using a mapping, they have a key value pair. The key will be the address, which is a token holder. And then the value is how many of that tokens they may hold. So that's why they have uint256. So I'm just going to copy that line. Cool. And then another variable which we're going to store is allowed. So with allowed, what you're effectively saying is, me, Alicia, I'm a token holder. I have this many tokens, but I might want another actor, another person, another smart contract to do some actions for me. And we are now going to give them permission to be able to transfer the tokens. I am an address, and I'm going to give some smart contract or account permission to spend this much. So in the mapping, the key, is my account. The value is now going to be all the addresses that can spend that token of mine and how much they are able to spend. So since there are two things I'd like to store, it makes sense to then make that another mapping. So then we have another key value pair of this smart contract, let's say RV, can spend this many tokens. This smart contract 1inch can spend that many tokens of mine. So that's why it's a mapping of a mapping essentially. So I'll just write that out. So mapping, address meaning me, the value is yet again another mapping, and this mapping is the smart contract I can spend and how much of my token they can spend. And the name of that variable is private, and we call it allowed. By the way, the underscore is just like a naming convention. In Solidity, you can only start off the name of a variable with letters or underscore. So some people use it for variables that are private, etc. And then there's another variable here called total supply. And this basically says how many of this particular token exists. So if I were to create my own token, maybe I want 100, maybe I want 100,000, maybe I want 1 million, maybe I want 21 million like Bitcoin eventually. So yeah, let's just copy that line because that's pretty simple. One thing we would like to do is implement the methods, right? So as you can see, there are many methods. So if we go to the ERC20 documentation, it does tell you what each method does, so you're not blind whilst you're implementing it. So let's go directly to the token standard. All right, so total supply returns the total token supply. I mean, that was self-explanatory, but I just wanted to show you here in the documentation. So what do you think we would need to do? Well, it does make sense to just simply return this token. I'm just going to copy this method and actually implement it. So I'm going to say return total supply. And if we look at how it was implemented here, that's exactly what they did. And then there's another method called balance of. So it says balance of who. So you'd like to return how many tokens that person has. So again, just going to copy this and implement it. So it does say who, and we do have a variable called balances, and the key is address. So that means we can pass the same who, which is the token holder, as a key. So I can say return balances who. And if this does not make sense to you, just bear in mind that, oh, I see some errors here. What's wrong? Yeah, just bear in mind that this is how you reference mapping. So if this format doesn't make sense to you, then just, do some research on how mappings work within Solidity. But essentially I'm using the key to find the value at that particular position within the mapping. By the way, I'm just going to change the accessibility to public. All right. Our function is missing override specifier. So I'm just going to say override. And then here as well. Perfect. All right, the next method is allowance. So we would just like to know for this particular person and for this spender, how much allowance did we get it? Like, can I spend all of the tokens? Can I spend just some? So we will then do function allowance. Well, actually, let me just copy this. And then we're going to implement it. So public override. And then we are then going to use this particular variable, which is called allowed. And so for this particular owner and for this particular spender, I'm going to return the allowance. And yeah, same thing that they did as well. By the way, you see how they format this here? This makes it easier to read. So if you want, you can just put everything on a new line so that you can just see everything better. Yeah, so that's that. Let's see what else we need to do. Transfer. So we're going to transfer value from my address to another. So going to make it public and then override. And then I'm going to, so to transfer value, essentially what is happening is I'm going to update how many tokens this particular address has. So 2. So we have a balances variable, and this variable stores how many tokens each address owns. So essentially what I would need to do is I would then say that this address 2 now is accumulating more value, the value that's passed in. And then the person who did have it, balances message.sender, the person who is calling this method, is now going to be decreased by that value. And I'm going to require that the balance, the person who's trying to implement this function or call this function, actually has that many tokens. So is actually more than or equal to that value. And if not, this entire thing will revert. This entire function will revert. And that should be it, but that's not it. So let's just see. So yeah, they're saying require that the value is less than or equal to message sender, and require that the 2 is not equal to the 0 address in the smart contract. I think that's smart. So they're basically saying make sure you're not sending to a 0 address, meaning an address that can't be resolved. So that makes sense. Message sender has less of that value stub, and the person who is the 2 who's receiving it now has more, and then they're just emitting that this happened. So basically writing a log that this happened. So as you know, there's this event transfer and approval. So I'm just going to paste that line and then return true because it happened. So one thing I would say that's different is, what is this error here? Oh, balances. Yes, I did mean balances. So one thing that's different is I'm using just basic arithmetic, but you see that they're calling some sort of method called sub and add, and that is using the safe math.sol, and that makes it so that whenever you're doing any operations, there's no overflow or anything bad happening. So I would like to use safe math as well. To use safe math, I'm actually going to import it like that. So now I have safe math, and then I'm going to add the line, what was it? I think it's using safe math. And then here, if I do instead balances is equal to balances to dot add value, that should hopefully work. Nice. And then I do the same thing for sub balances message dot sender, which is the person who initiated the transaction, is equal to balances message dot sender dot sub value. And that's that. So the other method is approved. So this function is essentially saying that I, the message or sender, or the person who's sending the transaction, is approving this particular address or spender to use my tokens. So remember, we also have a variable here called allowed, which stores who can do what to our tokens. We're simply just updating that variable with a new person or a new spender. So let's just copy the function head or the function signature. Right, and then change this to public and override. And then we're going to say that this method, we're going to say this message.sender, and then we're going to say the spender is equal to the value that we set. And then return true. Let's see how they implemented it. So they say require the spender's zero address. Okay, so requiring that you're not going to give permission to their zero address. That's a good shout. And then they're saying allowed is equal to the same thing I did, message or sender. So the person who owns the token and the spender, the person who owns the token is now associating that value, meaning how many tokens a spender can actually spend. And then we're emitting the approval because that is also an event that you emit as per the token standard. So emit. Sweet. So we're chugging along. So the final method is called transfer from. So again, it's the same thing, except it just specifies who's a front token. In the previous one, transfer, we assume the person who is doing the transfer is the one who's calling the transaction. In this one, we're actually just specifying from this particular address who are we transferring money from. So we're just specifying which address we're referring to. So you can imagine if there's another smart contract which has permission to spend your tokens, they will call the transfer from function because they're going to specify like, oh, this particular user would like me to transfer assets from their account to another account because maybe you gave 1inch permission to swap tokens for you. So just pasting that again, changing external to public, and then override. And then I'm basically going to copy this, except I'm going to change wherever I see message or sender to the from address. So from Be careful if they're copy pasting. This is actually a massive source of error. You may think copy pasting makes your life easier. Sometimes it makes it harder. A lot of bugs in my time have come from copy paste errors. Let's see if that's what they did. All right, so they're saying all right. Okay, so they're just making sure that the value Oh, makes sense. Because you remember, I told you guys a reason why you would like to implement the transfer from function is because you maybe give permission to one inch to spend your tokens from you. So in that case, it won't be message or sender who's initiating the transfer, because normally it would be one inch who's calling the transfer method. It'll be one inch who's calling it, which is the message or sender, but the person that you're actually transferring for is on behalf of someone else. So they're just saying that before one inch can even spend your tokens or transfer your tokens, we need to actually check to see if they're allowed to. So that's what this sign is saying. We're seeing if the person who owns the tokens from has given permission to message or sender to transfer that much value. So that's a good shout. And I'm just going to copy paste that because, I mean, otherwise, what's the point of giving someone permission if anyone can just transfer? So this is mandatory. And I don't know if you notice here, I do have it written a bit differently. I say where balances from is more than equal to value. It's the same thing the other way around. So if you guys just wanted to copy paste this entire token standard, you can. I just wanted to type it out myself. All right, so let's keep going. So there are some other methods that you can define within the ERC20 token that are optional, and they did not define, but I would like to define it because these are things that I think you will be used to using. So for example, the function name, the token name, the token symbol. So for example, a Shiba token, the symbol will be SHIB, I think is a symbol for that one, as well as how many decimal places. So you see these are strings. So I'm just going to define it here within my method, or within my smart contract, sorry. So I'm going to say string private name, string private symbol, and then string private decimals. Or was that uint actually? Yeah, uint. All right, so if I were to define those methods now, it should be easy peasy. And right, and then here, I'm just going to return name. Call those external. Symbol, do the same for symbol. So with strings, you have to explicitly say the data location. In this case, it's memory, which means it's temporary. And so I've made these ones private. So now I have to define the function, which returns string memory as well, and then string memory as well, and then the same for decimals. So let me just copy paste it. And what we can do is we can define a constructor, and in the constructor we'll say what we would like the token name to be instead of hard coding it. Could be nice. So constructor, we're passing name, symbol, decimals. And then of course we have to define what type of variable it is. So string uint 8, and then we just simply say name is equal to name. And then decimals is equal to decimals. Let's also define these as memory. And let's just change this name so it's not the same as the function names. We can even define the total supply here as well. So all right, so now we have everything really. So now I can compile my token. No errors except for some warnings like putting the license and stuff. And then I can also deploy it in the virtual machine. But when I deploy, I have to specify the token name. So I'm just going to call it Hello World. And then I'm going to make the symbol HW. Number of decimals, I'll just do 6 like USDC, or maybe I'll do 18 like ETH. And then total supply, I'll say there are 1,000 of these tokens. So very, very limited supply. And okay, my token is deployed. So I can see the balance of my address will be 0. And I can see that it has 18 decimals. The name is Hello World. The symbol is HW. Total supply 1,000. But let's say I wanted to transfer from one token to another, but right now I have 0 tokens. So how do I give myself tokens? I can either create a minting function, which allows me to allow anyone to just mint how many tokens there is available to be minted, or I can probably just give myself all the tokens to start with, because here's my token. So I think let's do that. So in the constructor, I'm going to say that the balances of message.sender, who's the person who's creating the token, is equal to the total supply. So I'll have all to begin with, and then I'll give it away. So since I am going to give myself all the tokens, that is technically like a transfer event from the 0 address. So I think it'll be good to emit a transfer. So it would say from to, so in this case, it'll be like, it's from no one really. So the 0 address, and then it went to message.sender. And then the value is the total supply. Boom. Okay, so then if I were to compile and then deploy again, obviously if I deploy, I'll say Hello World 2, HW2, 18 decimals, total supply 1,000. So now if I do that and I check to see the balance of my token, well, my address, sorry. Now I have 1,000 tokens and I can give it away to anyone who wants it. So right now this is not deployed on any blockchain. We will deploy it on the Celo blockchain. So I do have the Celo plugin. If you wanted to install the Celo plugin yourself, just go straight to the homepage, and then I think you go more, and then you search for Celo, and you could find the Celo plugin, and then make sure you also have the Celo wallet. I have the Celo wallet here. All right, so now when it comes to deploying my token, so I have my wallet connected and I'm going to deploy. So I'm going to deploy my token. I'm going to give it the name of HW, well, no, Hello World token, symbol HW, decimals 18. So the total supply would be however many decimals I like. So for example, if I would like my token supply to be 1,000, it'll be 1,000 multiplied by 10 to the power of 18. So there's this way to ETH converter, because 1 ETH is 10 to the 18 way. So if I know I would like 1,000 tokens, then that's how much way it is. So I'm just going to paste that in here, then do deploy. Going to deploy it. This is deploying on the testnet, by the way. Awesome. And now if I do a balance of my address, it'll be this massive number, which I can then use to convert here, and that's 1,000. So now if I'd like to transfer tokens from my wallet to another, so let's say if I say I'd like to transfer 100 of the tokens, so I'm going to give 10% of my net worth to someone else because I'm generous, then put that there. And then the address, I have another account here. Oops, gonna send it to myself. And then do transact. And yeah, so it's saying I'm sending 100 of my HW tokens plus the gas fee. But I'm sending 100 to the other address. And just wait for that to confirm. All right, so that seemed to happen nicely. So if I just check the balance of that token, it'll now tell me this number, which should be 100. Yep, 100. Okay, so that's it. Now you know how you can create your own ERC20 token, and you can take this code, deploy it to the main network, and transfer it to all your friends and keep building and doing cool stuff. So if you enjoyed this tutorial, then please subscribe to my channel and share it to your friends and anyone who you think would like to learn how they can build on the blockchain. And I will see you in the next one. Bye.